Hi everyone, welcome to ma2430, Probability and Statistics for Engineers. Today, let's talk about set notation. A set is a collection of objects. The objects in a set are called elements. So these objects can be anything. It could be like an apple, banana, and orange. This is a set, okay? But usually we just see sets of numbers. Look at example 1. Consider the collections of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So D is the set of, here we have the braces, and we put the numbers inside. So this is a set. And here we list all the elements, all the objects in the sets. This is called the roster method. So roster method simply just lists all the elements in the set. And then let's look at the next one. D is the set of X such that. So this vertical line means such that. Okay? D is the set of X such that X is a digit. So this is called the set builder notation. We're actually describing, okay, what are those numbers? Those numbers are digits. Okay, so this is set builder notation. Okay, roster method, we list all the elements. Okay, and set builder notation, we try to describe the elements. What are the elements? Okay, more examples. The natural number is 0, 1, 2, 3, ... Some textbook has the 0, some textbook does not have the 0. Okay, and then we have the integer. So the set of integer is -2, -1, 0, 1, 2, 3, etc. Okay, so here we are listing the elements. So these are the roster method. And then we have the rational numbers. So the rational numbers, they are P over Q, such that P, Q are integers. And the denominator Q can be 0. So this is set builder notation. Okay, and then we also have the real numbers and the complex numbers. Okay, the complex numbers is like A plus BI, where A, B are real numbers. And I, what is I? I is the square root of -1, right? So this is also the set builder notation. Okay, so next, relation between elements and set. So elements is the objects in a set. So that's why there are only two relations. Either the element A belongs to the set A. So this symbol looks like the C where you put horizontal line segments in the middle. So this means belongs to. Okay, so small a belongs to the set A. It means an element A is in a set A. For example, so we can always use example to help us understand. So example 2 is an element of the set 1, 2, 3. Okay, A does not belong to the set A. Not belong to, you just put a line just like cross out there. Okay, so this is the symbol does not belong to. It means the elements small a is not in the subset in the set A. Okay, so for example here 4 is not in the set 1, 2, 3. Okay, let's continue. Okay, so those are the relations between elements and sets. How about the relations between two sets? Okay, here are the notation. A equals B. Okay, so A equals B, or is equal to B. Two sets A and B have the same elements, then they are equal. For example, the set x such that 2x equals 4. Well, when we start for x is just 2, right? So these two sets, they're the same sets because they have the same elements. Alright. Other examples you can think about, okay, x such that x minus 1, x plus 3 equal to 0. When you solve for the quadratic equation, you get x is 1 or minus 3. This is another example that they are equal, right? And also our example 1, those two sets, they are equal. Okay, they're both the set D. Okay, next. This sign, okay, this is it means A is a subset of B. Subsets is like a smaller set, okay, which is contained in B. So it means every element of a set A is also an element of a set B, okay? And the notation is like the C, but you put a horizontal line segment under the C. So this symbol is belongs to, subset, okay? The belongs to symbol is you put the horizontal line segment in the middle, but now you put the line segment under the C, okay? So these means subset. For example, 1, 2 is a subset of the set of 1, 2, 3, because all elements in the set belongs, all the elements in this left set also belongs to the right set. So this is a subset. Okay, next. Furthermore, you can see 1, 2, 3 is also a subset of 1, 2, 3. It does not have to be smaller. It could be the same. Okay, so this sign means like equal. Okay, like equal. Alright, next. A is not a subset of B. It means there must be some elements in A, but not in B. So that's why A is not contained entirely in B. Alright, for example, 1, 2 is not a subset of 1, 3, 4. 1 is okay because it's also in the set 1, 3, 4, but 2 is not okay. Do you see? 2 is not an element of the set 1, 3, 4. Okay, so there are some elements in A, but not in B. Okay, next. Proper subsets of B. All elements in A are also in B, and there are elements in B that are not in A. So this is like you put a little cross on the small line segment. It means it's a proper subset. It's a subset, but it is not equal. So that's why here 1, 2 is a proper subset of 1, 2, 3. Okay. We can also use some analogy, okay, about this. All right. Think about numbers. Think about numbers. Like 2 equals 2, right? They're equal. This guy is like less than equal. So 1 less than equal to 2, but 2 is also less than equal to 2. That's why A and B could be equal in this case. And A is not a subset of B, so it's like 3 is not like less than equal to 2. Okay? And here, oops. Okay. And then here, this is like proper subset is like, so 1 is less than 2. So they're not equal, is less than. Okay? Alright. Next. we have the empty set. So the empty set, this is like the 0 and then you like cross it out, okay? So we can use this symbol, or we can just put brace with nothing inside the braces. So that means empty set or the null set. The set has no elements. Okay, so because it has no elements, so the empty set is a subset of every set. Because it has no elements, of course, it's contained in other sets. And caution. This guy is not empty. Okay, you either use this symbol or use that symbol, but you cannot use both. So this guy is a set and it has elements. The elements is the empty set. Right, we could have sets of sets. Okay, that's possible. We can have sets of sets. Alright, next. Union, A union B. Okay, so this guy looks like a U, right? But the U, you go down, but here you don't go down, you just stop right here. Okay, so this is union. It's the same as A or B, okay? The set containing all elements, those are either in A or B or both. For example, 1, 2, union 1, 3 is 1, 2, 3. Okay, we just put all the elements in the set. Okay, collect all the elements in both sets. Okay, so this is the union. Next, intersection. So this line is like upside down. It's also like N, but N is like this, right? So it's like U, which kind of draw like this. So this is intersection. So there's an N. Think about the N, intersection. So it's A and B. Okay. This is the set containing all elements. Those are in both A and both B. So you're looking for the common elements that are in both sets. Any guess what is 1, 2 intersect 1, 3? Which one is the common element? The element 1. Right, everyone? Okay, next. Set minus. A set minus B. We can use this notation or that notation. It means it's the set of elements those are in A but not in B. Okay? And be careful, we don't require B as a subset of A. Okay, it's like, okay, we look at the elements in A, and then we want to take out who's on the list of B. Okay, so think about, we start with the element of A, and we want to take out 1, right? We want to take out 1, and then we want to take out 3, but we don't have 3, so there's no 3 we can take out. Now, what's left? We only have 2. So A set minus B is 2 in this case. So is that okay, everyone? You start with the elements in A, and then you want to take out. Look at the list of elements in B. Whoever appear in B, you want to take it out. Okay? Alright, next one. Complement. So there's 2 notation for complement. You either put a horizontal line statement on A, or you can put a complement, C for complement. So this equals to S set minus A. So S is the universal set. What is universal set? Well, if you're looking for numbers, you think about, okay, maybe we start with the set of integers, and then we think about the sets of some numbers in the integers. So integers is like the universal set. Or if you want to talk about real numbers is the universal set, that's also possible, okay? So it depends on the problem. The problem usually will tell you which set is the universal set. Then the complement is the universal set minus the set A. Okay, so it's the subset of S that contains all the elements of S. Those are not in A. So in this case, if S equals 1, 2, 3, then what is the complement of 1, 2? Well, 3. Okay, which is in S but not in the set A. So far, so good, everyone. All right. So let's continue. Caution! Do not get confused about this guy is not a subset. So not a subset. And this guy is a subset and is a proper subset. Okay, so don't get confused about those two. So that's why when you write your solutions in your homework or exams, please make sure your handwriting is good enough so that I can see. You either put the cross right here or you put the cross all over, but don't put something like this. No, don't do this, because how do I know which way do you mean? Do you mean it's a subset, it's a proper subset, or it's not a subset? So don't write this. Okay, I need to be able to tell whether it's like this or this. Okay, very good. Let's continue. Let's look at some example. Example 2. Consider the following set where U equals the set of 2, 3, 5, 7, 11, 13, 17, 19. Oh, I think I missed a 9 here. So let me add the 9 here. Okay. So, and then A equals the set of 2, B equals the set of 2, 3, C equals the set of 3, 5, 7, D equals the set of 2, 3, 5, 7, 9, E is the set with the elements 3, 5, 7, 11, 13, 17. Insert the correct symbol. This is a subset, it's not a subset, belongs to or does not belong to between each pair. So I hope you can pause the video and try this problem. Okay, so it's good to watch the video because you can control the speed and you can pause at any time to think through the math, and you can also rewatch the videos. If you have questions, feel free to ask me. Okay, have you finished? Alright, let's check our answer. So first thing you do is you want to look at those two, the pair. Are these sets or is it like an element and a set? So B and E, they're both sets. So B is 2, 3. E is 3, 5, 7, 11, 13, 17. And you can see 2 is not in E. So B is not a subset of E. Okay, next one, 11 and D complement. This is D. D complement. What is D complement? It's in the universal set U, but not in D. Okay, you start with the universal set U, and then you want to take out the elements, those are in D. So you want to take out 2, 3, 5, 7, 9. So D complement, what's left? 11, 13, 17, 19. Is 11 in this set? Yes, it belongs to. So we use this symbol. Okay. Next one, C and D. Okay, you can see C, the element of C is right here. So C is a subset of D. Next one, 3 and C complement. So C complement is the U, we take out 3, 5, 7. So C complement is the set of 2, 9, 11, 13, 17, 19. Is 3 in C complement? No. So it does not belong to. C and E. So E also have those elements, right? So that's why C is a subset of E. Oops. Alright, next. 5 and C intersect E. Oh, do you remember? Like C is the subset of E, so when we talk about the intersection, this guy is just C, because C is the subset of E. So we just have 3, 5, 7, and 5 is in this set, so belongs to. Do you have the right answer? Alright, let's continue. Find the following. Part A, B and C complement. B is 2, 3. C complement. Oh, we already figured out C complement right here. So 2, 9, 11, 13, 17, 19. Okay, we're talking about intersection. So looking at the common element. 2 is the common element, 3 is not. Okay, so actually only the 2 is the common element. So this is the intersection. Next one, D intersects E. So D is 2, 3, 5, 7, 9. Intersect E, 3, 5, 7, 11, 13, 17. Okay, let's see. 2 is not common element, 3 is a common element, 5 is common element, 7 is common element, and 9 is not common element. So that's why the common elements are 3, 5, 7. Alright, do you have the same answer? Alright, let's continue. B complement union D. Okay, what is B complement? Well, B is 2, 3. Complement is we look at U and we take out 2, 3, and the other rest are in the complement. So 5, 7, 9, 11, 13, 17, 19. And then this guy, union D. D is 2, 3, 5, 7, 9. When we union all of them, well, do you see we just add the 2, 3 in the B complement? So we get 2, 3, 5, 7, 9, 11, 13, 17, 19. Wow, actually, that is U. Right? Okay. So we get the whole set. Part D. Well, part D, there are 2 sets, right? We first need to compute E complement union D, and then we want to compute that results intersects A complement. So let's first talk about E complement union D. E complement is E complement, so looking at the U and then take out E. So 3, 5, 7, take it out. 11, 13, 17, take it out. What's left? We have 2, 9, and 19. Union D. D is 2, 3, 5, 7, 9. So we get 2. And when you write down the number, it's better to follow the order, okay, from the smallest number to the biggest number. So 2, 3, 5, 7, 9, and 19. Okay, double check. Right, we have 2, 9, and 19, and we also have 2, 3, 5, 7, 9 in this set. So very good. Next one, we want to use A complement intersect all this. So A is just 2. So A complements will be the elements in the U when we take out 2. So, wow, that's a lot of numbers. Let's see. A complement intersect E complement union D. A complement is 3, 5, 7, 9, 11, 13, 17, 19. And intersect is 2, 3, 5, 7, 9, 19. Alright, what do we get? Let's see. Intersection, common elements. So we have 3, We have 5, 7, 9, and 19, right? Okay, so these are 3, 5, 7, 9, and 19. Do you have the same answers? Yes? Good. So let's continue. Okay, so this is example 2. All right, so we follow the order of, so here if you see the parentheses, it means we do this operation, the union first, and then we do the intersection later in the second step. Okay, good. Let's look at example 3. Example 3, consider the following intervals with the universal set as all the real numbers. So all the real numbers from minus infinity to infinity. Let me make this smaller. All right, so let's look at part A. A intersects B. All right, so what is A? Okay, in this case, it's better to draw a picture. All right, so we have the whole real numbers. A is from -2 to 4, so -2 to 4. -2 bracket means include the endpoint, so we put a solid circle here. Parentheses means we don't include the endpoint, so we put a open circle on the 4, right? And then A is between them. So this is A. Next, what is B? B is 0, 5. 0 is somewhere here, 0, and 5 right here. And they're both parentheses, so we put open circle right here. And this is B. Okay, now how about the common region? We're talking about intersection. So intersection means the common region. So this common region, okay, is 0 to 4. And we don't want to include 0 and 4. That's why we put open circle on 0 and 4. So far, so good, everyone. Okay, next, part B, A and C. So let's draw a picture. A, -2 and 4. Include -2, exclude a 4. This is A. C, what is C? C is -3 right here and 3 right there. And we want to include them, right? And then this is C. And now we're talking about the intersection. So the common region. So this is the common region. And you see we include -2 and we include the 3. So far, so good? Now please pause the video and work on part C and part D. Have you finished? Let's check our work. So B complement. What is B complement? So B is 0 to 5. Well, the complement, so B is inside 0 and 5, and the B complement will be outside of 0 and 5. So 0 here, 5 here. And because B does not include 0 and 5, then the B complement will include 0 and 5. And it's outside. So this is B complement. Okay? So you just check whether the endpoint, if the endpoint is in the B, then it's not in the complement. If the endpoint is not in D, then it is in the complement. Okay, D is minus infinity to -3. -3 right here, and include that. So this is D. When we talk about the union means all the region under those lines. So in this case, union is like everything under the lines. So it would be minus infinity to 0, include that. And then we put union because it's like 2 intervals. So that's why we're going to take a union there. And then 5 to infinity. So far so good, everyone. Yes, if you see there are more than two or 2 intervals, then you want to use this union notation. Okay. Part D. Well, part D we also have 2 steps. Okay, first let's compare what is C complement union D. C is -3 and 3, so -3 and 3, because C includes the endpoint, so C complement does not include the endpoint, it's outside of this region, -3 to 3. Okay, so this is C complement. Union D. Wow, what is D? D is minus infinity to -3. You see? Here we include -3. And when we talk about the union, well, union is going to be everything under it, right? And we also include the -3. So it will be minus infinity to -3. Notice that bracket, union 3 to infinity. So this is C complement union D. Okay, we're not done yet, because next step we want to compute A complement intercept with that. Alright, let's write it down here. So -3 and 3. Okay. A complement. What is A complement? A complement. A is -2. -2 right here. 4 right here. A complement, because A includes -2. The complement does not include -2. Because A does not include 4, then the complement will include 4, and then it's outside. We are talking about intersection. Well, intersection is the common region. Okay? Oh, maybe I should use purple color then. Okay, intersection, the common region. Alright, and this is minus infinity to -3. Okay, and what? And union 4 to infinity. So far, so good, everyone. So this is the answer. Do you have the same answers? Good. Okay. So this is about sets. Let's continue in the next video. See you soon.